Welcome to Theory of Computation in Practice, Real-World Applications and Industry Relevance. In this video, we will explore how the abstract concepts of theory of computation translate into practical solutions that drive technological advancements. Prepare to journey from abstract theory to practical solutions. So, what exactly is the theory of computation? It is the mathematical study of computation, algorithms, and computational systems. This field provides the theoretical underpinnings for computer science, helping us understand what problems can be solved by computers and how efficiently they can be solved. It is the study of abstract machines to automate the process. The theory of computation consists of three primary areas. First, Automata Theory, which deals with mathematical models of computation and abstract machines, such as finite automata and Turing machines. Second, Computational Complexity, which examines the resources, such as time and memory, required to solve computational problems. This field classifies problems based on their inherent difficulty. Third, Computability Theory, which explores the limits of what problems can be solved algorithmically. It addresses questions like, can all problems be solved by a computer? The concepts from theory of computation find numerous practical applications in the real world. Let's explore some key areas. First, security and cryptography. Theory of computation is crucial in designing encryption algorithms, ensuring digital signatures are secure, and underpinning blockchain technology. Secondly, artificial intelligence and machine learning. It plays a vital role in neural networks, pattern recognition, and natural language processing, enabling machines to learn and understand complex data. Theory of computation is fundamental in compiler design and the creation of programming languages. One key application is the use of finite automata in lexical analysis, where state machines are used to tokenize source code, recognizing patterns in keywords. For example, in this code snippet, the lexical analyzer identifies tokens such as if, parentheses, identifiers greater than numbers, and so on. Theory of computation is also essential in database systems and network protocols. In database systems, automata theory optimizes SQL query parsing and execution plans, enhancing database performance. In network protocols, TCP/IP protocols utilize finite state machines for connection management, ensuring reliable data transmission and network stability. Understanding theory of computation is highly relevant across various industries and significantly impacts career opportunities. Key industries include tech giants such as Google and Microsoft, financial services, cybersecurity firms, and research institutions. Career opportunities for those with knowledge in theory of computation includes roles such as software engineer, research scientist, algorithm designer, and system architect. In conclusion, the theory of computation bridges abstract mathematics with practical technology. It serves as an essential foundation for modern computing careers and technological innovation. Thank you for joining us on this exploration of theory of computation in practice. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.